So remember, the two triangles you need to produce, they get you these middle three rows here. The unit circle gives me the other two rows of the table. So with what we've learned so far between the unit circle and the special triangles, we can answer exact value for these, let's see here, 1, 2, 3, 4, 5, well, let's do it the smart way, 1, 2, 3, 1, 2, 3, 4, 5, these 15 angles, okay? Now, we can do a lot more than that, because these are for reference angles. When we apply the cast rule, that means if I can do 30, I can do 150, because 30 is the reference of 150. If I can do 30, I can do 210, I can do 330, keep going, right? So there's many angles we can do as long as they fall into this for a reference angle. So let's try this and see exactly what I'm talking about. Sometimes I don't know, so let's take a look here. So we'll determine the three trig ratios for the following angles. Okay, so 780 degrees, let's start with that. So for 780 degrees, what quadrant is that in?
1.
You know who I find are really good at these questions, are really quick?
1.
Snowboarders are really quick at this. Why is that? Ming, are you a snowboarder? Sometimes? Right, so this is a 720, right? It gets you back to where you started, and then 60 more degrees, which means you wiped out, but you're still in quadrant 1, okay? So the reference here is 20 degrees, and that would be a quadrant 1 angle. Oh, sorry, 60 degrees, not 20. 60 degrees. Okay, and we know it's quadrant 1, so the cast rule tells us what about this? Everything's positive, right? So now what we do is we go back up to our chart, and we look at 60 degrees, and here are the values that I'm going to get for the three trig ratios. They will all be positive. So I can write them in. They are root 3 over 2, 1 over 2, and root 3. Okay. Now, one thing I encourage you to do, and you're going to watch the way I do these from now on, I'll show you what I do. It's tempting to just think, all I'm going to do is memorize this chart, and I'll just write the chart down before I do my homework, or I'll write the chart on the first thing I do before I write my test. But that's not going to help you get it much further, right? Because then, you know, you're not really using the idea. I'll show you how we do this next one here, and we'll see a little more general way of doing it. So negative 1035, okay, so this is like, I guess if this was a front side spin, this is a back side spin, so you're going backwards now. So where does it end up? It's close to 1080, right? So what quadrant are you going to be in if you didn't get, you're going backwards and you didn't get quite all the way around?
1.
You're still in 1, right? Because you weren't going the, yeah, you're going the other way. So this is a quadrant 1 angle. Do we know what the reference angle is? 45 is the reference angle. So here's what I'm going to do. This is the way you're going to start doing it in Math 12 as well, is when you know your reference angle, that should trigger you to then say, which triangle is this? The first triangle, the isosceles triangle. So what I'm going to do in my margin is I'm going to go like this. And I'm going to go 1, 1, 45, 45, root 2. Okay? So now I can use the triangle to get all three ratios. The sine is the opposite over hypotenuse. The cosine is the opposite over hypotenuse. And the tangent is the opposite over adjacent. Why would you also want to be able to do this instead of just reproducing a chart? Well, these are typically a written section question on the government exam for Math 12. Meaning you need to show all your written work, and you get marked for your written work. So if you just have some memorized chart work, I don't know how friendly they're going to be to marking stuff that doesn't really show your understanding. It just kind of, you throw it out there that you memorized it. Whereas if you give them a triangle to show how you got the ratios, then they know what you did to find your answers, and they can give you full marks. Okay, so let's try one in radians. No. You're going to like radians. Here's one reason radians works out nicely too. What's the reference angle here? Pi over 4, that is correct. 45 degrees or pi over 4. Let's try and stay in radians. Okay. What quadrant are we in? Yeah, quadrant number 3. This is pi plus pi over 4. So that means what we've done is we've gone pi plus pi over 4, so it puts me over there. Now one thing you're going to notice, at some point everybody seems to notice this, because of the way the fractions work, it actually shows you your reference angle. It's the same denominator. If we were to go here, this is like negative 2 pi minus pi over 6. Well, guess what that is? That's the reference angle. So in radians, one nice thing is it's easy to see your reference angles. Okay? We said this was quadrant 3. So what I'd like you to do is produce a triangle and come up with the 3 ratios for these sine, cosine, and tangent of 5 pi over 4. And I'll catch up to you. Okay, so what triangle did you come up with? If it's pi over 4, which triangle is this? It's the first one, 45, 45. It's the Isosceles Triangle. So we could use the same one again, root 2. And that means it's the sine for the first part here. It's going to be 1 over root 2. But I'm in quadrant 3, so it should be negative 1 over root 2. Okay? So we have to apply the cast rule to those numbers. Sine is negative when it's in quadrant 3. Cosine, what will the cosine be in quadrant 3? Positive, negative? Negative. It's going to be negative, so I'm going to end up with negative 1 over root 2 as well. And what about the tangent? What will the tangent be in quadrant number 1? Positive. Tangent is positive, sorry, in quadrant number 3. It's going to be 1 just positive. Okay? Okay, and in the second example here, which quadrant are we going to be in?
4.
Yeah, it's going to go negative 2 pi, so that's going to be backwards 2 pi, and then a little bit more by pi over 6. So we're in quadrant number 4. Our reference angle is pi over 6. Pi over 6, let's connect it to something familiar. What is it in degrees?
30.
It's 30 degrees, so the triangle that we're looking for looks like this. Root 3 and 1. So that's the triangle that we would want to use here because it has 30 degrees in it, or pi over 6. So to get the sine, it's going to be the opposite over the hypotenuse, which is 1/2. Will it be positive or negative?
Negative.
In quadrant number 4, which is down here, that's going to be negative. Okay, what's the cosine of pi over 6 going to be?
Positive root 3 over 2.
That is correct. So the whole thing, the cosine of negative 13 pi over 6 will be negative root 3 over 2. And what about the tangent? Or sorry, positive is what you said. I don't know why I wrote a negative. Okay, and what about the tangent?
1 over negative 2.
Yeah, so it'll be negative, and it'll be 1 over root 3. Okay. Any questions on how we go about those exact values using our triangles? Okay, let's take a look at where this actually, what this actually looks like. This is more like what we're going to see when we get to Math 12. We're actually going to try and solve some equations. So I'm going to walk you through the first one, and then I'll let you try a couple on your own. So now we've got to work backwards. What we have to do is, instead of saying which triangle has pi over 6 degrees, we're trying to say which triangle has root 3 and 2 in it. The second one has those pieces in it. So here's the second triangle where I had 1, 2, root 3. This would be 30 degrees. And this would be 60 degrees. Okay? So what I'm going to do now is I'm going to try and work backwards and figure out which angle did it have to be if the sine was equal to root 3 over 2.
60.
Yeah, 60, because I want the opposite side over the hypotenuse. So theta had to be 60 degrees. Can anybody think of another place where it might have been the answer? Good. So this time we have to think a little bit further ahead. What we're going to do is we're going to look at our cast rule. We're going to say this is positive. So I may have answers here or here because that's where the sine is positive. So there could be 2 answers, right? It could have been 60 degrees here, or it could have been the angle with 60 degrees as its reference, which is 120. So this has two answers, theta equals 60 or theta equals 120. So try tangent 0, try cosine theta equals to negative root 2 over 2.